We see a number of companies that are out there that have a significant number of spikes in their daily shipment volume when they're doing deployment to their customer-facing DCs. So one day they might have 2 trucks, and next day they might have 20 trucks. And what's driving this? Friday, Saturday, and Sunday, weekend, basically 70% of all grocery sales happen. So you and I go to the store and we buy from the shelf, and so we have gaps. And the store sends a signal back to the DC, their supplying location, which is traditionally a grocer. So grocery DC, they replenish over time. That, however, then sends a signal to the supplier DC. They replenish. And now the system says, oh, we need to replenish that inventory in the customer-facing DC. So they go out and order back to the plant and say, you need to ship me a certain amount of product. So if we have a spike here, that generally goes through, and we have a bit of a bullwhip effect. But that's only one implication. One of the other challenges is that these planning systems are generally very sensitive because their goal is, I need to be on shelf 97% of the time, 98% of the time. And that says, oh gee, if I see some perturbation in demand, I therefore have to react by creating an increased safety stock. It may say, oh, hold on, I've got a problem here, so I need to perhaps send 500 cases more just to act as safety stock. The problem is the system thinks that's equally urgent, and so we then create a spike of half a truck of additional volume that we're going to ship. And unfortunately, this happens across lots and lots of items, so we therefore see these horribly expensive spikes in the supply chain that are generating a whole bunch of additional cost.